Ladies and gentlemen, welcome. This presentation was brought to you by the Vigilant Society of Engineers. I thank you for giving me the opportunity to share it with you and to all electrical working professionals in the field. This presentation focuses on electrical motor. It's understanding the motor circuit as well as the control using the National Electrical Code. Now, the motor converts electrical energy into mechanical energy through the interaction of magnetic field in the stator and the rotor. Motor output is traditionally rated in horsepower. Now, motor is sized based on the input current or its full loaded current. So the amount of current that is received through the motor is what we use to design the conductor ratings for that motor. Right? Now the efficiency measures the output and it depends on the power factor and the losses experienced in the motor. Now we're gonna go into the construction of the motor, and this construction is typical of most motor, and most motor consists of a stator, right? And the stator is responsible to deliver the power to the motor. Now it comprises rather of slots on the periphery and distributed the coil, and it's also form the pole pairs. Now the stator is the core, and it forms the frame to the foundation for the motor. Next part we're going to explain is the rotor. So the motor comprises of a rotor, and the rotor is cylindrical in form, and it may have slots on the periphery, right? The rotor also consists of conductor, and this conductor may form from aluminum, brass, or copper. The conductor is placed in the slots and enclosed by an end ring. Now, this motor we are referring to in this diagram here is an induction type motor. Alright, so we're going to choose one typical motor that is regularly used in the industry, and this one is the induction type motor. Alright, the induction type motor consists of a squirrel cage rotor, alright, and this consists of copper bars, and at the end there's a pin which helps to provide heat transfer or cooling. It also describes or illustrates the pole pairs for the motor, right? And the pole pairs with the core of the motor provide interaction, right? So this interaction creates rotation for the motor. Figure 3 gives us an open view of the motor, right? And this is how it will look in its final stage, with a more solid core for smoother rotation. Now the motor consists of windings, right? And the diagram shows how the windings are distributed around the core or the stator of the motor, right? And as it is shown, these windings are polarized. So we have two pole pairs in that description there. Alright, so this motor that we're going to speak about is the induction type motor. Induction type motor are special motors. They are very common in the industry, And the induction type motor, right, it operates like a transformer. And it uses rather the principle of electromagnetic induction. So the primary armature winding of the stator transfers power to the secondary of the rotor, and the current intensifies until they both lock in together at synchronous speed. So the principle of the induction motor is to transfer energy from a primary to a secondary, and the energy that is in the secondary interacts with that of the primary, right? So the current transfer to the rotor, and the rotor create an interaction between the stator. Alright, so the rotor chases the field winding at a slip speed relative to the revolving stator field. So the rotor tries to catch up with the stator. The stator is revolving at synchronous speed. Right? Basically, this revolution of the stator is actually the revolution of the field. So the field is revolving, and the revolving field is creating interaction with the rotor. The rotor builds up a current in it. It creates a magnetic interaction between the stator, and then it tries to catch up to the speed of the stator. The central part of a motor comprises of a branch circuit conductor. It comprises of a disconnect means, comprises of branch circuit, short circuit, and ground fault protections. Right? It may also give us or highlights rather the motor controller. Right? So that's another part which take in consideration as well. Another essential part is the motor overload protective device. Right? So the illustration that we have there is showing us the motor full essential parts. Alright, so we have the motor in the description. However, the parts that we are going to need in building out our motor is the branch circuit conductor, its disconnect means, and branch circuit, short circuit, and ground fault protection, right? And motor controller, which is the diagram on the right, and the motor overload protective device. Capacity rating of the motor. So the ampacity rating shall be calculated in accordance with 310.15B16. This is what we use to size electrical conductors, and also it is used for motor circuits or conductors as well. The ampacity of the motor shall be used to determine the conductor size of the ampere rating of the switch, or the switches, short circuit, and ground fault protection. Feeder conductor supplying motor shall comply with the following, that is, 125% of the full load current rating of the highest conductor motor as determined by 430.6A. Now, any additional motor should be added to the largest motor that is included in the circuit. Alright, so in the case where there's a single motor, we shall take 125% of the full loaded current of the rating of the motor to size the feeder conductor. Now the motor disconnect. A motor has a disconnect means. The disconnect means shall be permitted of two separate components. right? The one to disconnect the motor, and the other, which is a controller, to deactivate the source of power. Alright, so the motor should be arranged to disconnect all sources of power. Alright, so the disconnect means that the motor should isolate all the phases of the power at the same time. The protection that is needed for the motor. Right? So motor branch circuit and ground fault protection and overload protection shall be permitted to combine. Right? So the fuse shall not be smaller than what is required to accommodate for the fuse of that motor, as specified by table 430.52. Alright, so all the protective devices should be in series with each other. Right, when we combine them. Circuit breaker, the next protective device we utilize for these motors. Alright, our motor protection. Circuit breaker include ground fault and short circuit protection and shall have a current rating according to Article 430.52 and 430.10. Overload protection device is intended to protect the motor control apparatus. Alright, as is described or illustrated in this diagram. The branch circuit conductor against excessive heating or protect against excessive heating due to overload. Right? So the overload protective device protect the motor from lock rotor condition or failure to start. So this overload protective device shall protect each phase of the motor. So when even if we experience an overload condition on each phase, then the motor overload protection should provide isolation for the motor. Any additional friction in the motor shall lead to overload condition. Alright, and this condition is typically detected by an overload protection device. Nameplate rating. The nameplate rating should provide the input current to the motor, the service factor, ambient temperature, voltage, and speed. It may also give us the horsepower rating of the motor. Right? So as this diagram illustrates, right, it will give us all these specifics. More so, it will tell us how to connect the motor. So I can use this diagram here and know exactly how am I going to make these connections. Alright. So understanding the motor nameplate. The nameplate will help us to establish the following understanding, such as the design of the feeder and the branch circuit conductor. The nameplate will help us to understand the size overload protective device that is needed. It will help us to know the switch gear that is needed and the wiring arrangement for the motor. And yes, also shows the operating voltage for the motor. Okay, so thanks for watching. Please like and share and subscribe to our channel and register to our engineering community at the Vigilant Society of Engineers.com. Thanks and take care.